diagram is drawn there, so you can find that they are at random motion. So you already said the molecule space between them, they are in constant motion. The experiment you can see in it. By that way, we came across the three things. That is, they are very, very small particles. How small they are. They are so small that it cannot be seen. The order of their smallness is almost 10 to the power minus 10 meter. This term is called angstrom unit. The size of particles are as small as 10 to the power minus 10. That means if you divide 1 by a number having 10 zeros after 1, such a small quantity will be called the size of particle. So that is called the size so small. So the particles are there. Like, next one is they have the force of attraction between them. Why do particles live together? They have some interactive force present in them. They have intermolecular force of attraction, which we'll say IMF. IMF means intermolecular force of attraction. Molecules attract each other. That is the reason that substances are compact, like solid. Substances are like liquid within a container. They cannot cross the limit of their positions. They can move around within the boundary only. The particles can move around the boundary of the liquid. In solid, they can vibrate, so there is no question of any boundary. But what about gases? Gaseous particles can move all around anywhere they are free, because they have a very large amount of intermolecular space. Liquids have little less amount of intermolecular space, and solids do have the least possible intermolecular space. How much it is, I said, around 10 to the power minus 10 meter. So these are the four features. And in this connection, these properties can give rise to the thing that it says that molecules, they do exist with their most fundamental features like all this. Now, I must speak about that activity number 1, activity number 2, activity number 3, also there activity number 4 and 5. They can be read and understood clearly, and for any doubts and questions you can contact your elders or the persons that you feel like for any doubts as such, because these features I have just explained to you that why they have to do so. Now the thing comes, molecules attract each other. They have this tendency because of a nature that which is free from electrostatic force or gravitational force. Because you know, these two forces also magnetic. These forces can attract a body from distances. Gravitational force, bodies can be attracted by distance, from a distance. Magnetic force, the magnets can pull the magnetic substances towards themselves without any contact. And third is electrostatic force, that is also can pull one another with the opposite charges, positive and negative charges. Like charges will repel. I think this you have already read somewhere in some of the cases of your study. If not, then we must name these three, that these are the three methods generally where the forces can become invisible and they invisibly act. One is gravitational force, body left here can flow down to the earth, magnetic force and electrostatic. But these molecular force of attractions are not at all a gravitational force or an electrostatic force or a magnetic force. These two have the force of cohesion and force of adhesion. These two names are there. Force of cohesion, when like kind of molecules are attracting each other. Water body will attract water body quickly. Water is there in this beaker. If I empty the beaker completely, you will surely see that some water parts are sticking to its inner surface of the body. Water is there, some part is still sticking to its body. This is one way. The other way, water molecules are attracting water molecules to be together. So like molecules attracting each other is called force of cohesion or cohesive force. Force of cohesion or cohesive force. And the second one, that is different kinds of molecules, if they attract each other, like water molecules, the glass molecules, they are attracting each other, that is called force of adhesions. So what happens there? That all the adhesives what we are using nowadays to stick a paper, stick something to one object, we put a paste in between. A paste in between. Suppose if I want to put one substance just sticking to this blackboard, of course I need to have some sticking substance. I am trying to do with water at present. Maybe that I have just put some water in it. It is just sticking there. What is actually happening here? It is a molecular principle. It is a molecular principle that when this paper was dry, if I try to put it that, it will fall. I just put some liquid. I don't have any other thing except water. So I tried with water. I found that water is just making a space over here, and just I put some water in it. I took it to the wall. What happens? Water molecules and this board molecules, they are different of kind. Water molecules and the board molecules are different of kind. So they are attracting each other. That means molecules of this board is attracting the molecules of this water. And the second part, the other face of water, which is now towards the paper, that paper is attracting the next layer of molecules of water to itself. So what is happening? Water is becoming a buffer. Water is becoming a buffer between these two surfaces. One is the blackboard, the other is the paper. In between there is a layer of water. Water is functioning two ways here. One, it is getting attracted towards the blackboard molecules, and one way it is attracted towards the paper molecules. So what happens there? The paper got stuck there. Now time when this water will dry up, they will simply slide down from there and they will fall, because the buffer is absent. The one which is trying to help to pull the molecules of two different kinds to itself is absent. Then this will have a fall. This shows, this is an example of adhesive forces. from these terms only. Any sticking gums and all we call generally as they are adhesives. From this term only called adhesives. As your book suggests here, we say the states of matter, though it is not very much unknown to you of class 8 boys. I'm sure about it. You know quite a lot of things, maybe something more what I can tell you here. That I'm sure, because you're reading it from lower classes and also you have the idea. That is the kinds of substances there is, as it is called, the states. States means conditions. The states of matter we know. I just speak up, you just hold in mind. The solid state, liquid state, and gaseous state. I repeat, solid state, liquid state, and gaseous state, gaseous. Normally in many books and other places, and people also speak as a solid liquid gas. Gas is not the name of a state. Gas is actually the name of a substance. Gas is the name of a material. So it is better to use the term as a states of matter by saying solid state, liquid state, gaseous state. Don't write simply gas state. States means conditions. Matters can be found in these three conditions. One is the solid state, second is the liquid state, and third is the gaseous state. Mind it, it is gaseous state. gaseous. The solid state, it is a molecular property. Molecules are very, very close and compact. Molecules are very, very close and compact. How much close I said? Close order I said 10 to the power minus 10 meter, as it is the smallest particles, so their closeness must be within a nanometer, that is 10 to the power minus 9 meter. That is called a nanometer. This much of the space minimum should be there. So it is a solid molecule, solid particles. So within that particles, because of kinetic energy, though it has a very low kinetic energy, it will vibrate, it will bounce, it will come back and forth. It will go up, come down, go left, come right. It may go forward, it may come backward. So any movement it can make, but it will be within the spaces. So that's why solid is very closed and compact. It is hard. Its surface is hard. The hardness is there. It has very small space in between, very, very small space in between, of order 10 to the power minus 9. If the space is more than that, then this force of attraction will decrease. This force of attraction decreases because of the space. If it is increased, the space increasing, force of attraction will decrease. So it has the highest, the greatest amount of intermolecular force, but very, very small intermolecular distance. So it has a small IMS and high IMF. You can say it has a small IMS and large IMF. It has a small kinetic energy, low kinetic energy, low kinetic energy. So it cannot move very fast. They are living together. Closeness is very much high. So these particles, these solid substances like that. So they occupy constant